Welcome to my How Healthy Are You weekly educational podcast. My name is Dr. Thomas Brewer. I'm a PhD chemist and nutritional blood microscopist. Today is June 20th, 2022, and this is podcast number 126. And it's going to be on skin science. And during this podcast, you're going to recognize a few of the words that I'm using. They're actually scientific terms, but I'm sure you've heard them before, and this will probably help you understand these words. So diving right in, the skin is really a barrier. It has amazing chemistry, a lot going on in the skin and on the skin, and it's considered an organ. So it's a visible organ on the body. It's even part of our immune system. In fact, so it's the beginning of our immune system. It's a physical barrier, but there are three layers. All three layers work together. So if you're going to remember three words, here are the three words to remember: epidermis, dermis, and hypodermis. So the epidermis is the topmost layer, the dermis is in the middle, and the hypodermis is the lowest layer, so digging into the skin. I'm going to talk mostly about the epidermis, a little bit about the dermis, and then very little about the hypodermis. So the epidermis is the outermost layer, and these cells make something called keratinocytes. And so that is an important word. It's going to come up a lot. These keratinocytes, which are cells, they make keratin. You've probably heard of keratin. It's a protein, and hair is made of keratin. So these keratinocytes are most of the epidermis layer, and these cells assemble very tight. And as they get tightly packed, it makes a waterproof barrier. Hence, our skin is a waterproof barrier. Now, it takes 4 weeks for these keratinocytes, which are cells, to move up from a lower layer of the epidermis all the way up to the surface of the epidermis. So it takes 4 weeks for them to move up to the surface, and this is really important because if this happens too fast, there's a problem. We're going to get to that. So basically, you have new skin every month, every 4 weeks, and the other skin that's getting replaced as these keratinocytes move up, the old ones are brushed off or flake off. So this is why we leave skin cells behind when we rub our skin or when we put on clothes, and this is why criminals get caught if they're not careful because they're leaving their DNA behind during a robbery, because these skin cells are constantly falling off and getting replaced. Now, if there's too much rubbing of these skin cells, these keratinocytes, then the cells start growing faster, and therefore you get a callus. So that's how a callus forms. It's from rubbing these keratinocytes too much, and that's how you get a callus. You get them from lifting weights or swinging a baseball bat or working in a yard, always doing something repetitive in the same area of your skin. So it is a way that our body protects us, but if it goes too far, this is what eczema and psoriasis is. So eczema and psoriasis is the same concept where the keratinocytes start growing too fast, and I'm going to talk more about that in a little bit. Now, the other thing these cells do, these keratinocytes, is they make vitamin D3 from UV light as the energy source, and this vitamin D3 goes to the liver and makes the really good kind of vitamin D, which is 25-hydroxy vitamin D. This is the form of vitamin D that people were getting injected when they were sick with COVID and they had to be hospitalized. It's too late for them to take vitamin D because it takes a few weeks to make this 25-hydroxy vitamin D, so they were getting it directly. The epidermis also has a different type of cell called melanocytes. Now, that term probably sounds similar to melanin, and that's exactly what happens. Melanocytes, which are cells, produce a black pigment, and that black pigment is melanin. You've probably heard of melanin, and genetics actually influence our skin color from white to yellow to brown to black, and that's what determines the color of the different races. Vitiligo is when these melanocytes die and stop producing melanin. So that's people that have that white skin color. In fact, I believe Michael Jackson had that, but don't quote me on that. But vitiligo. Now, cells that kill microbes are also in this outer layer, this epidermis, and they're activated by something called cytokines. And cytokines, again, I'm sure you've heard that word before, because if there's too many cytokines, we have problems, but we need them for an immune response to kill off bad bacteria. So too much of these cytokines, you get inflammation, and not enough, well, you can't kill microbes that would hurt you. There's also T-cell lymphocytes in the epidermis layer, and T-cell lymphocytes are a type of white blood cell. They're immune white blood cells, and if they're overactive, that's another way to get psoriasis. So the keratinocytes move to the surface in just days versus 4 weeks. Remember I said it takes 4 weeks and your skin changes. These keratinocyte cells move to the surface in 4 weeks. Well, during psoriasis, they'll move to the surface in just a matter of days. All right, moving on to the middle layer, the dermis, and that's where blood and lymph vessels are. So blood vessels and lymph vessels. Lymph is different than blood, but it's still a circulatory system. So there's also sweat glands and nerves and hair follicles. So these are things I wasn't talking about for the top layer. The big thing about the dermis layer is it's able to regulate body temperature through the blood flow, because there's blood vessels, and through sweat, through the sweat glands. So there's also these finger-like projections that reach into the epidermis layer. This is important because it prevents the dermis and the epidermis from sliding over each other. But if it's rubbed too much, these projections will pull away, so we don't have this connection. Fluid builds up in the gap, and that's how you get a blister. So a blister is when your dermis and your epidermis are actually rubbing against each other, and these finger-like projections actually pull away, and so you have a problem. There's also a phagocyte-type white blood cells, again, for microbe protection. Anytime I say white blood cells, think of immune system and microbe protection. So the dermis layer has a lower half and an upper half. The lower half has elastin and collagen. Now, elastin is really important because if it's stretched too much, you get stretch marks. So when people get stretch marks, either having a baby or lifting heavy weights too fast, if you grow too fast, you'll get stretch marks. It's the elastin fibers. Now, there's also collagen fibers in the dermis layer, and these fibers have peptide bonds, and they can break from UV light exposure, meaning sun exposure. They also will break when sugars combine with proteins, and I talked about these many weeks ago, these advanced glycation end products when I was talking about longevity. So both of these cause wrinkles. So when the collagen fibers have peptide bonds that break, either through sun exposure, which is UV light, or sugars causing these advanced glycation end products, both of those cause wrinkles. Finally, the lowest layer is called the hypodermis layer, the deepest layer. Sometimes it's called the subcutaneous layer. Another term I think you've heard of, you've probably heard of subcutaneous fat versus visceral fat. So subcutaneous fat is fat, well, near our skin. Obviously, it's a hypodermis layer. And then visceral fat, much harder to get rid of. This is the fat that's near our organs. So normally when we exercise, the first fat that gets burned or reduced is the subcutaneous fat. So a term we've heard of. Now, the hypodermis layer has nerves, oil and sweat glands, the hair roots, and essentially this hypodermis layer connects our skin all the way to the inside, to the muscle and bones. So that's what I have for this week's podcast. Thank you for listening, and as always, please don't keep me a secret.